P of k is the smallest prime that doesn't divide k. Capital X of k is the product of all the primes that are less than P of k, with the exception that if P of k is 2, then X of k is 1. And then we have these sequences. Solving for x sub n plus 1, we take the previous number x sub n, multiply it by p of x sub n, and divide by capital X of x sub n. And we're given that x sub 0 is equal to 1, so we'll start with x sub 1. This is the previous x times p of x sub 0 over capital X of x sub 0. x0 was 1. We're now looking for the smallest prime that does not divide 1. The smallest prime is 2. 2 doesn't divide 1, so that's our result. Now we're looking for capital X of 1, where P of 1 is equal to 2. That means the denominator is 1. So X sub 1 is equal to 2. For X sub 2, we'll take the previous X sub 1, find P of that, and capital X of X sub 1, which is 2. The smallest prime that doesn't divide 2, it's not 2, the next one is 3. Now we're looking for all the primes that are less than 3 and taking the product. The only prime less than 3 is 2, so x sub 2 is 3. For x sub 3, we'll take the previous number 3 times p of 3 over x of 3. The smallest prime that doesn't divide 3 is 2, and since p of 3 is equal to 2, then x of 3 is equal to 1, so x3 is equal to 6. We have 6 again in the numerator, and we're looking for the smallest prime that doesn't divide 6. We exclude 2 and 3, and the next prime is 5. And then we're looking for the product of all the primes that are less than 5. That's 2 and 3. Cancels out the 6, so x4 is 5. Similarly for x5, 2 doesn't divide, and then since this is 2, our denominator is 1, and x5 is 10. x6 is going to be 10. 3 doesn't divide 10, and we have 2 down here, so this is 15. We'll do a few more. 15 times 2 and a 1, this is 30. We're looking for a prime that doesn't divide 30, not 2, not 3, not 5, so we're up to 7. And then the product of the primes less than 7 are 2, 3, and 5. So we're left with just 7. We'll take 7, 2 doesn't divide 7, and this is 1, so we're at 14. 3 doesn't divide 14, and we have 2, so this is 21. Let's table our results and see if we can find a pattern. I don't see a pattern yet, and since we're dealing with primes, let's write these in terms of their prime factorizations. We notice that each of these numbers is the product of a prime raised to power of 1, and it looks like it's sort of building on itself, adding an additional prime and then multiplying by the previous smaller primes. This starts to remind me of a binary sequence. This will be clearer if I write the primes up at the top in decreasing order. So we don't have any primes in 1. 2 is a prime here. 3 is a prime. Now we have 2 and 3, and then our next number is 5. And we can see how this increases. This looks like n written in binary. We'll fill in the rest of these. We're looking for t, where x sub t is equal to 2090. At this point, I'm hoping that 2090 is the product of primes raised to the first power. And when we find the prime factorization, we're relieved to find that this is true. So I'll list out the primes from 2 to 19. We have a 19, 11, a 5, and a 2. So t is the number when written in binary, and we can write it as the sum of these powers of 2. So our answer is 149. If you'd like me to solve any other contest problems, please leave them in the comments.